Hi, welcome to Math in the Class with ClassCalc. My name is Daniel, and today we'll be solving for a linear system of equations. So our special Spooktober math problem this week is this system of linear equations, where we have these three equations, and we got to basically solve for x, y, and z. Now in math, there's a general rule, and I say general because it doesn't always apply, but 95% of situations where if you have a certain amount of variables to solve, you need that same amount of equations. So here we can see we have x, y, and z. We have three variables. And we also have three equations, the first, second, and third one. So we can assume that most likely we'll be able to solve this. Now, there are many ways to solve this. You could use matrices actually, you could do it algebraically. Today, we're gonna solve it by using the elimination method. So we'll go ahead and jump right into it. Starting off with equations 1 and 2 and applying an elimination to them. So we have equation 1, which is 5x minus 2y minus 3z equals negative 7. Then we have equation 2, where we have 2x minus 3y plus z equals negative 16. Now, to apply an elimination, we got to multiply one of these equations by something to make the variables cancel out. And we're going to tackle z because that looks like the easiest one. It's the only one that has a coefficient of 1. And to get these two to cancel out, we'll need to multiply this entire equation by 3. That's going to give us 6x minus 9y plus 3z equals negative 48. Now, we could already see how the two 3z's will cancel out if you add them. If this doesn't make intuitive sense to someone, think of it like this. If I had two equations, and using very, very simple math is a great way to make the more complicated things make sense. So if I have two equations, 5 equals 5 and 6 equals 6, you'd say that both of those are true. Now, if I add these two equations, right, I would get 11 equals 11, which is still a true statement. That's really all we care about. So you could do the same thing here. You're adding the left side to the left side and the right side to the right side. Now, ignoring this one in the middle, right, we're going to get 5x plus 6x is 11x. Negative 2y plus negative 11y is minus 11y. Negative 3z plus 3z is going to cancel out, and that's going to equal negative 55. Now we could leave it like that, but actually I noticed that all of this, the entire equation is divisible by 11. So we're going to go ahead and divide that by 11, or factor that out, and get x minus y equals negative 5. And that's going to be equation number 4. We'll use that for later. Next we got to use, so that was these two, right? It gave us 4. Now we're going to use these two to give us equation number 5 and apply the same elimination pattern. So we got 2x minus 3y plus z equals negative 16, and 3x plus 4y minus 2z equals 7. Again, we're going to go ahead and multiply this one by 2. And that's going to give us 4x minus 6y plus 2z equals negative 32. To get rid of the z's, we're going to have to add them. So 2z plus negative 2z is going to give us 0. Now we add the 4x and 3x, which will give us 7x. And negative 6y plus 4y will give us negative 2y. On the other side, we're going to get negative 32 plus 7, which will give us negative 25. So now we have our two equations. X minus y equals negative 5, and 7x minus 2y equals 25. And from here, you can see it's going to get a lot more simpler, because now we're just dealing with two equations and two variables. So we'll now go ahead and line those up and create a little space for ourselves here. We'll go ahead and line those up. We'll get 7x minus 2y equals negative 25, and x minus y equals negative 5. We're going to multiply this equation by 2, so we're going to get 2x minus 2y equals negative 10. And to get rid of those, we're actually going to have to add it this time. So negative 2y minus, subtract them this time. Negative 2y minus negative 2y is going to be negative 2y plus 2y, which gives us 0. 7x minus 2x, we're going to have 5x equals negative 25 minus negative, right? So we've got a minus negative 10, so that's going to give us negative 15. So that gives us, we're going to zoom in even more to create space, that gives us x equals negative 3. Plugging that back into here, this 1, we got our x. Plugging it back into there, we get negative 21 minus 2y, wow, we're really running out of space here, equals negative 25. Which, when we solve for that, we'll get negative 2y. We add 21 to both sides. So negative 2y equals negative 4, and y equals 2. That's going to give us our second equation. Now to find the third one, we'll have to go all the way back to where we had our initial equations with the z in it. And we'll have to plug in x equals negative 3 and y equals 2. So we're going to go ahead and use this one. Equation number 2. That's going to be 2 times negative 3 for x minus 3 times 2 for y. Sorry, negative 2 for y. That's 2 for y. That's correct. 2 for y plus z equals negative 16. There we go. Fit it in there. And now we just solve for z. So we get negative 6 minus 6 plus z equals negative 16. Which will give us negative 12 plus z equals negative 16, which will give us z equals negative 4. And that's the correct answer, folks. It's going to be negative 3 to negative 4, where this is x, negative 3 is x, 2 is y, and z is negative 4. And you could always check them, right, by just plugging them into your original 3 equations. And they should all come out true. If even one of them come out false, you might have been doing something wrong. So you could easily check them by always plugging in x, y, and z into these 3. Well, that's it for this week's math problem. For questions or comments, please feel free to reach out to info@classcalc.com. And make sure to let us know in the comments below what you might want to see in the future weeks. We always love to hear from you guys.